Dear student, welcome to UV learning class. Managed by Modern University School Nawada. Dear student, myself Sujay Kumar, your mathematics teacher of Modern University School, New Area Nawada. Student, this is the second part of video of exercise the circle. Theorem first and 2 already in first video. So now we see up to theorem 3 of the theorem of the circle. So now see here is the theorem 3. The lengths of tangents drawn from an external point to a circle are equal. So your question is, it is a circle and from external point there are two tangents are drawn from P. One is PA, another is PB, and external point is P, and circle are, let's see what is a circle. So first you write given. What is given here? Here let COR is a circle from an external point P, PA and PB are two tangents to prove. Your question is here that from an external point the length of the tangents are equal. So it is clear you have to prove PA is equal to PB. Now construction. Join O to P and OA and OB. So dear students, first we join O to P, OA and OB. So now prove, when we join OP, then you get here are two triangles. One name is in triangle AOP and triangle BOP. What is given? Here given OA is equal to OB due to radius, and angle OAP is equal to angle OBP. It is 90 degree because radius perpendicular to the point of contact of the tangents. Here PA and PB are two tangents and A and B are the point of contact, and in first theorem the radius and the point of contact are perpendicular to each other. So OAP is equal to OBP 90, and third OP is equal to OP common. OP is equal to OP common. Hence triangle AOP congruent triangle BOP by RHS, because here is hypotenuse, here is one side and one is right angle. So in this theorem we use the property of congruency RHS. Hence by CPCT you can write PA is equal to PB proved. So dear student, your question is the length of the tangents drawn from the external point of the circle, then the lengths are the equal. So first you draw a circle. Suppose let's COR is a circle and PA and PB are two tangents drawn from the external point P, and you have to prove that the length of PA is equal to length of PB. So we join the radius to the point of contact and also join OP. Then from after joining this OP, you get there are two triangles, and then find the congruency relation between them, and you get it by RHS both triangles are congruent. If both triangles are congruent, then it is clear you can write by simplicity PA is equal to PB. So it is the third theorem. Now see your fourth. Now see theorem 4. If two tangents are drawn from an external point, then that means question is that the two tangents are drawn from an external point. So here is a circle and two tangents are drawn from an external point. Suppose P is the external point and two tangents, that is P and PB, are drawn. Then if two tangents are drawn from an external point, then they subtend equal angles at the center and they equally incline to the tangents. That means the equal angle makes at the center. That means you have proved this angle is equal to this, and after that also they equally incline to the line segment joining to the center to the point of contact. Equally inclined to the center to the point of contact. So you have to prove this angle is equal to here this angle. So dear student, first you write what is given. So write given, let COR is a circle, PA and PB are two tangents. P and PB are two tangents. To prove angle AOP is equal to angle BOP and angle APO is equal to angle BPO. Now proof construction is no need here. So proof, you take in triangle AOP and triangle BOP. What is given? You can write that is AP is equal to PB. Reason, from external point tangents are equal. AP is equal to P. Next Next you write OA is equal to OB, and this is the radius. And third, OP is equal to OP. It is common. So by yes triangle AOP congruent triangle BOP. Hence by CPCT angle OAP is equal to angle OBP, and similarly angle APO is equal to angle BPO. So it is proved. So dear student, your question is that that two tangents are drawn from an external point. We draw here two tangents, one is PA, another is PB from an external point. Then they subtend equal angle to the center. So we join to the center of the point of contact and join a line segment to the external point of this outside of the circle. Then you have two questions here. You have to prove that angle made by these tangents at the center are equal. Tangent is here and angle made at the center is AOP, another tangent is PB, and that made at the center is BOP. So first proof is AOP is equal to BOP, and next they equally inclined to the line segment joining to the center to the point of contact. Here is the center and here is the point of contact. When we join it, then this angle also make equally inclined with this line segments. So first you find the congruency relation between them. You can also find the congruency relation by RHS method, but in this question I solved by SSS method because PA is equal to PB already proved in theorem 3 that from an external point the length of two tangents are equal. So I used here that PA is equal to PB. From external point the length of tangents are equal. Next OA is equal to OB, that is the radius, and we know that radius of the circle are equal. And third OP common, therefore these two triangles are congruent. Then by simplicity easily we can write that this angle is equal to this angle and other two angles are also equal, hence by simplicity. So easily you can solve this theorem by when use the congruency theorem of SSS. Now theorem 5, that it proved that in two concentric circles the chord of larger circle which touches the smaller circle is bisected at the point of contact. Here is given there are two concentric circles. So dear student, first what is the concentric circle? Two circles are called concentric circle if the center of two circles are equal but radius are the different. Here are two circles which center is O but different radius. Another is the chord of larger circle which touches the smaller circle. A chord of larger circle, suppose it is a chord AB and touches the smaller circle at the point of P. Then you have to prove that it is bisected at the point, that means AP is equal to PB. So first you write what is given. You have given let C OR and COR dash are two circles. Why write here R and R dash? Because the radius of these two circles are different, but center are the same. So I suppose here the first circle which center is O, but radius is R. But next circle in the center is O, but radius is not R, it is R dash. So let COR and CO dash are two circles, and AB is called of larger circle. AB is called of larger circle and P is point of contact of a smaller circle. Then you have to prove that this AP is equal to PB. Point of contact is P, then it is bisected of AB, then AP is equal to P. Now construction. Join OP, OA and OB. So you join here OA, OB and OP. And you have to prove that is proved. You have to prove that AP is equal to PB. Then it is clear when you find the congruency relation of these two triangles, then you can clear way you can find AP is equal to PB. So we write in triangle APO and triangle BPO. What is given? You can write OA is equal to OB. Both are radius. I write here R. Both are R in the larger circle. Next, angle OPA is equal to angle OPB. It is 90 because it is the radius and it is the point of contact, that is what I say tangents. AB is the chord of the larger circle, but AB is the work at the tangents of the smaller circle. Because this AB touches the one and only one point of the circle, then it is clear that AB is the tangents and P is the point of contact. So in the first theorem, you know about it, that radius and the point of contact of tangents is always perpendicular to it. So we can write that OP is equal to OPB is equal to 90. And third, OP is equal to OP. It is common. It is common. So triangle AOP congruent triangle BOP by which theorem? It is 90. One is hypotenuse, another is one side. So by RHS, it is. Hence by CPCT, you can write that is AP is equal to PV. So it is proved. And it is given that OP bisected the AP. So dear student, in this question here given that there are two concentric circles and the chord of the larger circle touches the smaller circle at a point. Then when we join from the O and P, then P is the point of P divides this AB into two equal parts. Otherwise, you can say P bisected AB. So first we write what are given. Here given let COR and COR dash are two circle and AB is the chord of larger circle. P is the point of contact of a smaller circle. Construction join OA and OB, and now find the relation between OAP and OPB. You get here that OA is equal to OB, it is the radius. Next you get OP common, and third APO and BPO are 90 because OP is the radius and AB is the tangent of a smaller circle. So by RHS both triangles are congruent. Hence we can write by CPCT AP is equal to PB. So if AP is equal to PB, you have to prove. So it is proved. Now see theorem 6 that prove that the tangents drawn at the end of the diameter of a circle are parallel. So dear friend, first you write it is a circle and it is the center and AB is the diameter. I write A and B is the diameter. So at the ends of the diameter we draw a tangent. So here we draw end of diameter, that is PQ, and here we write ends of the diameter, that is RS. Here is RS and here is PQ. You have to prove this PQ and RS are parallel. So first you write what are given in your question. So first it is given that let COR is a circle. Let COR is a circle. AB is the diameter. AB is the diameter. AB is the diameter. And PQ and RS are the tangents. To prove, we have given what is to prove. To prove is PQ parallel RS. Construction, know anything? Proof. If AB is the diameter, then OA is the radius. OA is radius and PQ is tangent. So OA perpendicular to PQ. So OA perpendicular to PQ, that means this angle is 90. So clear way to write angle 1 is 90. Similarly, OB perpendicular to RS. So angle 2 is 90. I write here angle 2. So it is 90. Because the radius and tangents are perpendicular to each other at the point of contact. So here is second. From first and second, you get that is 1 is equal to 2. 1 is equal to 2. But these are alternate angle and equal. You write here, but these are alternate interior angle and equal. So PQ parallel arcs. So dear students, your question is that prove that tangent drawn at the ends of a diameter of a circle are parallel. So first we write that let CR is circle and AB is the diameter and the end of diameter are A and B. Your questions when draw a tangent at point A and B, then these lines are the parallel. So I write first PQ at the point of A, it is the end of the diameter, and other RS at point B, it is also end of the diameter. Then you have to prove that this PQ are parallel to RS. Now I write that here is OA is the radius and PQ is the tangent. Then it is clear this angle 1 is 90 degree because here is the OA radius and PQ is the tangent, and we know that from the theorem 1 the radius are always perpendicular to the point of contact of the tangents. So this angle is 90. Similarly, OB is the radius and RS is the tangents and B is the point of contact. So OB also perpendicular to the RS. Then angle 2 is 90 degree. So from equation first and second, angle 1 and 2 are equal. If these angles are equal, really these angles are the alternate angle, and due to reason these are equal, then it is clear if these two angles are equal and it is alternate angle, hence PQ parallel to RS. So dear students, now remain questions you try to solve. I think today is the last class of this session of video classes. Next we meet in classroom, and now remain theorem you solve in classroom from Monday. So thank you dear students.